Hi guys, welcome to the first workshop of the day, and we already have our speaker here. We'll wait for 5 more minutes and then we'll start the workshop.
Hello everyone, am I audible?
Yeah, Ankit.
Cool. So let's wait for 5 minutes as Shubin told, then we can start our workshop. So how many of you have before worked with Docker or used Docker in their development or learning stuff? Anyone?
You guys can unmute yourself and speak up if you want.
Yeah, let's make this interactive. I don't want to bore you guys. If you'll speak, I'll understand it. How much do you know about Docker, and then I can start accordingly. So is a hackathon going on? Anyone working on some cool ideas or something?
Yeah, we still have 3 minutes, so you guys can share anything, whatever you want about your project, the speaker. Okay, just 1 more minute and then we'll start the workshop. Hello.
Yeah,
Yeah, Ankit, you can start the workshop.
yes, hold on. Hello everyone. So a little information about me. I am Ankit Jain. I am currently working as an infrastructure engineer at Rizapay. Before that, I was working as a DevOps engineer at Atlanta. And this is my Twitter handle, Ankit28May. Moreover, you can find me with this handle at anywhere, Instagram, Facebook, or everywhere. And this is my email address. Okay. So let me introduce you what is Docker. So Docker is an open source platform for developing, shipping, and running applications in isolated environment. So what is isolated environment? Isolated environment is an environment where one application is completely isolated with our host OS operating system. So so let me give you a brief history about Docker. So Docker is founded by Solomon Hykes in under .cloud uh, SaaS company in 2011, and it is being open source in 2013 March. So and Docker is not so how Docker runs applications in an isolated environment. So Docker uses LXC. It is called Linux container. So generally we call Docker containers. So Docker uses Docker containers to run an application in a completely isolated environment. So Docker container is not the very first container that runs the applications in isolated environment. Docker uses LXC containers. So LXC containers were the first container that is quite like similar or perfect for running application in an isolated environment. So Docker is written in Go and it uses LXC, that is Linux container, and it has enhanced our Linux containers so that it can run application in a more optimized and efficient way. So now the question comes, why can't we use VMs, virtual machines? So I'll tell you about that too. So Docker allows you to package an application with all its dependency into a standardized unit for software development. So what happens before? So when we suppose a person A has created an application or product and he has created this on Windows. So when he wants to run this application on some other system, suppose Linux or Unix, so he needs to tell that you need to download these dependencies and these dependencies. Now the question is, the dependencies are system uh, tightly bounded. So if he's working on Windows, many of the dependencies are only downloadable to Windows, or they need particular version to be run on the Windows rather than Ubuntu or some other Linux version. So what Docker does, Docker is a loosely coupled environment with system OS. It runs applications irrespective to any system in an isolated environment. This gives an edge over other applications, or this gives an edge to Docker that it is so popular nowadays that all of the applications are being containerized or running in an isolation environment, so that it can easily run on any system, any operating system, and any environment. Either it is Linux, Unix, Windows, or whatever it is, even Mac. So this guarantees that it will always run the same regardless of the environment it is running in. So any doubts? So why can't we use VMs? So like before Docker, we use virtual machines to run applications, in virtual VMs. So like as we can see in the figure, this is a major difference between containers and VMs. So as we can see on the left hand side, there is a server and then host application and then hypervisor. So what is hypervisor? Hypervisor acts as an interaction interface between our VMs and the host operating system. So all our requirement dependencies of application are being are being interfaced to host OS using hypervisor. So we have Docker daemon in containers. It is being as an interface between our application and host OS. The major difference that we can see in VM and container is there is a guest operating system. So what it does is when we launch any virtual machine, it reserves some amount of operating system named as guest operating system to every virtual machine. While in Docker, while in containers, we don't provide any guest operating system to containers. It is being so our host operating system is a shared operating system that is being used by all the containers. So in this way, that gives containers an edge over VM, that it is fast, lightweight, as it saves disk and CPU, portable software. We can easily containerize an application and then push his image to Docker registry. That I will explain you later what is Docker image and Docker registry, and we can like share it with other people, other developers. Microservices and integration. So before we use monolithic application, monolithic architecture to create applications. So what is monolithic architecture? In monolithic architecture, we create all the things in a single stack, like a project A, project B. Suppose A has dependency on project B and project B has dependency on project C. So what we does, we create project A, B, and C in a tightly coupled manner. So like if B is not working, then A will also not work. So in this way, there is a tightly coupled architecture. This is called monolithic architecture. While in microservices, we keep it loosely coupled. So project B has its own dependencies and it will run in an isolated container, while project A has its own dependencies on libraries and it will run in its own isolated container. They won't depend on each other. But if project A has some work from project B, then it will call project A in a client server architecture manner. So this is why we have started using microservices as compared to monolithic, because it is easier to debug in case of any errors. It is easier to use project B with other services or other projects as a library to some other application or as a dependency to some other application. It is simplifying our DevOps architecture and DevOps tasks, because it is very easier to run Dockerized applications on cloud platforms like AWS, GCP, Azure, and many other. Version control capabilities. So we can also version control our projects. Suppose in similar to Git, that we have a lot of versions, we push anything and we can version control our things. Similarly, we can create multiple images of the same application with different commit IDs or with different tags. That tags acts as a version that we generally have in GitHub, Git releases, Git tags. So these all are version control capabilities that Docker also comes up with. So a brief about Docker architecture on the basis of OS. So as I've already told, it uses Alexi. Alexi is a Linux container, but but Docker has optimized Alexi so it can be more efficient, more optimized, more fast. And how it is using Alexi? So Alexi uses Linux kernel, and the main important thing about Linux kernel is it uses namespace and this one C group. So namespace provides Linux containers or Linux kernel the ability to to set the CPU resource and other system resources to a particular process in an isolated manner. And C groups helps the process to make it run efficiently by providing it proper system resources like CPU, memory, and other things. So these both are these two components like C groups and namespace are the most important factor of the success of Linux kernel, Linux containers, and then the Docker. So the main component of Docker is Docker engine. So what is Docker engine? Docker engine is comprised of three main components. Guys, you know now what I am telling. Are you able to understand? Or do you have any problem? You can ping me and stop me. If I'm going in fast or slow, let me know. Okay. So Docker engine is comprised of three main components. The one is Docker daemon, that is server. Second is REST APIs, and the third one is client, Docker client. So Docker actually follows client server architecture, where client by the ping server through REST API. So similarly, Docker daemon is our server. It is a long process. It is a long running task or process. And our REST and client, our Docker client is a CLI tool by which we interact with our Docker daemon. So REST API. So REST API are the interface between client and the server. So suppose we want to tell Docker daemon to run an application or to start a container. So by using a Docker client, we tell our Docker daemon to run any container, and Docker daemon performs the task according to our Docker client. So Docker client manages containers, images, networks, and data volumes. These are all the things that we can also use with Docker. We can manage our containers, images, networks, and data volumes as well. So Docker architecture, as I've already told, it follows a client server architecture. So whenever client runs any command, like here we can see that the client is running Docker build, it goes to a Docker daemon, that is our server, through REST API calls, which performs a particular task. Suppose we are building an image, so it will build an image. If we are pulling an image, it will pull an image. If we are running an image, it will run an image. So and registry. So what is a Docker registry? Like similar to GitHub, like Git. What is the basic difference between Git and GitHub? Can anyone tell me? Okay, cool. So Git is a basic version control application, a tool, while GitHub is a collection of repos where we store our Git repositories. Okay. Similarly, our Docker images, Docker registry is a collection of Docker images, a collection of Docker repos where we store all the images that we can share along with our other developers, and we can also make them open source so that other developers can also use them. So this is a minimal Docker architecture. It uses a client server architecture. Cool. So let me tell you about Docker images. A Docker image is a file comprised of multi-layers used to execute code in a Docker container. So what is a Docker image? Is a set of executable commands that is written in Docker file. And when we build this image, or when we run this Docker file, which contains a set of commands, executable commands, it creates an image, which is called Docker image. So suppose in OOPS language, what is Docker image? Docker image is a class. So with a class, we can produce as many instances, that is objects, as we want. Similarly in Docker image is a class which can produce as many Docker containers as we want. An image is essentially built from the instructions for a complete and executable version of an application which relies on the host OS kernel. Yeah, so Docker image is the main build component of Docker. Without Docker image, we can't run any Docker container. And these are the portable things, like Docker image is the main portable component main portable object. Docker images and Docker objects, Docker containers are the objects of Docker. So this is a main portable object that can be distributed among other developers and can also be open sourced, by which a developer can run his own isolated container. So what is container? A container is a running instance of an image. They are lightweight, fast, portable, and encapsulate an environment in which our application runs. The environment is called isolated environment. Why it is called isolated environment? Because we are not interacting directly with the host OS, and it is not dependent on any other libraries except the libraries that is coming with its container only. We can create, start, move, and delete a container using Docker API client or CLI. So Docker client, Docker CLI is a Docker client by which we can create a new container, start an existing container, stop an existing container, delete or move the container. We can connect a container. We can also execute, or we can also SSH into a container. We can connect a container to one or more networks, attach storage. We can also mount a volume to an existing container so that the volume can be persistent. Otherwise, a Docker container, the volume that Docker container comes up will be running, will be ephemeral. So it is available for the time being, it is running. After the application is stopped, the container is stopped, and we have removed the container, the volume attached with the container is also deleted. So to make it persistent, we mount the volume from our OS host to this Docker containers. We can also attach a network. We can also create new networks and attach our existing container to a network. So suppose we have Docker container A, Docker container B, and Docker container C. So we want Docker container A and C to be in the same network so that they can talk to each other. So we can create one network, network A, AC, and we can connect container A to network AC and connect container C to network AC. Now container A and C can talk to each other via the network AC, while container B still can't talk to A, can't talk to C, because there is no network attached to container B. So it doesn't know about the address of container A and container C. These are the following Docker commands that we are going to use in our demo or workshop. So Docker help, Docker info, Docker network ls to list the networks, Docker images to list the images, Docker pull to pull the image, Docker run is used to run the container, Docker ps is used to list the Docker containers, Docker start and stop and restart is used to start, restart or stop the containers, stats to show the states of the container, and rn to remove the container. Cool. Let's do a hands-on. Anyone has any doubts? Or we can start with the demo. Cool. I'm starting the demo then. So before starting the demo, hopefully you all have the Docker installed in your system. You can check. You can check whether you have Docker installed or not by running Docker help. So Docker comes up with two editions, commercial edition, enterprise edition, while Docker open source version of Docker. So I'll have a Docker community edition 19.03 version. So let's pull an image, Docker pull hello world. Hello. So let's pull hello world image. So the image is being pulled from Docker Hub, that is Docker registry, open source Docker registry. Let's see the image that we have pulled recently. Uh, Docker images. So as you can see, we have hello world image here somewhere. This one, Docker images. We have hello world latest. So let's run this image, Docker run, and the name of the image, it is hello world. Hello from Docker. This message shows that your installation appears to be working correctly. So this is the basic image that Docker provides to check whether your Docker is running perfectly or not. So let's start our demo. So everyone is used Nginx. So whenever we run Nginx, we can see something. We can see this page. We can see this page. Welcome to Nginx. Welcome to Nginx. If you see this, the Nginx server, web server is running. So suppose you want to install Nginx, but not on your local OS, local system, but you want to run this Nginx server as a Docker container. So what you need to do, you need to pull the Nginx image. So let's pull the Nginx image. So this is the tag latest. So this tag is basically used as a version control. You want to run like Nginx, some version you want to download, so you can provide the version as a tag to Nginx, to image, to download that particular image. So Docker pull Nginx latest. It looks like you have asked some questions during my talk, but I was not able to see. Let me check. Okay, I'll answer all these questions after this workshop. Cool, during a QA session. So we have pulled our Nginx latest image. So let's run the container of Nginx. So Docker run. Let's run help what the flags that Docker run comes up with. So these are all the flags that Docker run command comes up, like to add host, to attach a container, to pass environment variables to a container. to provide a memory, mount a volume, publish a port. You can expose ports. So let's run docker run, and we can pass ports. So suppose Nginx by default runs on 80 port, but we want us in our local to expose 80 port on our host, which maps to 80 port in a container. So let's run 80 or 8000 80 and the port of the Docker container 80 Nginx latest. So this is the name of the image, Nginx latest. This is the port that we have exposed on our local system, and this is the port of our Nginx container, Nginx image. Currently. So there we can see the logs. So our container is up and running. Let's go and run localhost 8080. Cool. So our application is running now. Awesome. So let's make some changes. Let's close the container. Docker ps check the container. Docker ps dash is so to stop show the stop containers. This is our container. Let's remove this container. Docker rm. Cool. So let's create a Docker file. So I've already created a Docker file to use Ubuntu as a base image, as a container, and install Nginx in this. So recently we have already configured Nginx image that we have used to run an Nginx container. Suppose we want to have a container that is being configured by us only. So suppose we want to run multiple applications, or want to install multiple applications in a single container. So let's suppose we have taken a Ubuntu server. So this is a basic format of Docker file. Docker file is a file which contains a set of instructions by which a Docker image is being built. So I'll tell you what is Docker file and how to build an image from Docker file. So let's comment all this. So there is a statement called from. From is an instruction where we use the basic image, which is served as a main image for our container, where we will download all the dependencies, libraries, or install or run any other application. So let's use Ubuntu 18.04. You can find the images here on Docker Hub, or you can run Ubuntu 18.04 Docker image. You can see Docker Hub Ubuntu image. So this is a Docker official image for Ubuntu. So we will be using 18.04 tag. Let's search for 18.04. This is our 18.04. It is being updated 3 days ago. So from Ubuntu 18.04, now run. So this command indicates the commands to be executed inside a shell. So let's apt get update and apt get install Nginx -y. So this will install our Nginx. First it will update the packages inside Ubuntu, and then it will install Nginx. Now expose port. So this is used to expose the port that our application use inside the container. So we have exported the 80 port which Nginx uses by default. Now entry point Nginx G daemon off. So now we will be running Nginx application. So there is two commands, that is, one is entry point and other command is command. So the basic difference between entry point and CMD is you can override CMD command during Docker runtime by passing docker run, and the name of the image name, and then commands. So here the commands that we have passed after the while running a container is being overridden by the default commands that we have passed here. But with entry point, whatever there is in entry point is always run irrespective to commands passed as a command line. So let's pass this as an entry point right now. And now let's build this image. So docker build, let's check for the arguments that we need for building image. So we can use F to name of the Docker file. By default, it takes a Docker file, or you can mention the path or whatever the file name. So Docker build the tag. This is used to tag your images like Nginx demo or Docker workshop demo something. Let's tag the image Nginx demo Ubuntu and dot is used to tell the context for building Docker image context. So it whenever it is building file, whenever it is building a image, if suppose we have some commands there, we will copy some files from a local OS to our image in our image. So this context tells which is the current context that we have to mount in our image during building. So suppose we want to mount the context of project that it will be mounted, or we want to mount something like node, the contents inside the node that we can also pass as a context. So we want to mount current contents of a folder. So let's run this command. So it has run these steps. Step 1 from Ubuntu 18.4. It has first pulled this image Ubuntu 18.4 and then run this command expose 80 port, and it has built our image. This is the like SHA or some unique port for our image, and this has tagged our images in Nginx demo Ubuntu. So let's check our images. Docker images grab Nginx. Okay, cool. So we have our image demo Ubuntu. Cool. So let's run this image. Docker run. Let's expose 9090 port this time on our local system and 80 port inside the container, as Nginx is running by default on 80 port, and pass our image Nginx with tag docker demo Ubuntu. Cool. Let's create another container and check docker ps grab Nginx. So we can see that our Nginx container is running from last 10 seconds. Cool. Let's check localhost. It's running on 9090. Okay, so it is running. We can see welcome to Nginx. Awesome. Let's stop this container now. Or you can use command like docker stop. And let's remove this container as well. Docker rm, remove the container. Any questions? If you can't speak, just write in the question. Just write.
Yes, there are some questions. Okay, you can
Okay,
check them.
cool. I'll answer these questions. Any questions during this workshop while running images or building images? Cool. Then I'll continue. So let's create another file index.html, and we will run docker. We will run hello world inside our Nginx container. So now what we need to do is we need to copy this file. So we have already installed the Nginx. Now let's, by default Nginx host where www/html directory, the content concept of layer caching. So every command here.
The broadcast is now starting. All attendees are in listen-only mode.
So all the commands here are a set of instructions are itself called a layer. So each layer can be cached here. So it is using a cache. So like as we can see, these commands are all commands that we have previously written. So it is using cache, but as we can see, these commands copy and expose are the change command. We haven't mentioned it before. So from the point where we have made any changes in a Docker file, or the content in the Docker file is not being cached, it will build again or run again. So copy the file, expose. All the commands after the changes are also not cached. Cool. So we have also created a new image with demo hello world. Let's run this image. Docker run p here p, let's run 9091 this time, and 80 nginx demo hello world. Cool. So let's check whether the container is running or not. Docker ps grep nginx. So we can see our demo hello world is running. Let's run this as well. 9091. Awesome. Hello world Docker. So we can see that we can mount we can also copy our images from our local system in our Docker containers. Any issues? Am I audible? Cool. So let's run a simple Node application. How many of you have worked on Node? Anyone? Have used Express now? So I've written a small Express application where I will simply deploying congratulations hello world, running this application and sending the output congratulations hello world on port 9000. So let's run this. Cd node index.js. Server started port 9000, localhost 9000. Congratulations hello world. So let's start dockerizing this application. So I'll be deleting all these things. Cool. So let's create a new file, docker file, and now either we can use Ubuntu 18.04 and install node inside Ubuntu, or we can use node image from Docker Hub. Let's find the node image on Docker Hub. Node Docker image. So I can see node Docker official image. I can take a particular tag, or I can find the tag here as well. Let's run latest of 14.1. Okay. So remove this node. Seems like my internet is slow. 14. So we will be using 40. Here it is. It's there. Cool. Let's use 14. 14. Now we will copy our package.json file package, or you can do copy dot run mkdir-p/app. So this will create our directory /applications. Now let's use working directory. So working directory is used to change our working directory. So suppose we are in some directory /abcd and we want to be in a directory ab or app or abc, whatever. So we can set working directory /app. So all our commands after setting this directory will be executed within our working directory /app. Now copy all our data from local to working directory. Copy dot and dot to our application, or you can use this. So let's do dot. Cool. Now entry point node index.js. So here node modules also being copied directly, or you can do run npm install and npm update. So it will install all our npm node modules, and then we will run our node index.js. Let's expose our port. Expose 9000. Cool. Any issues? So docker build docker build tag nginx demo in dot. So it is pulling our node 14 image from Docker Hub and then perform the operations or instructions. Install our dependency and created our image node demo. We can see our image here. Node demo. Cool. Let's run this in Docker run. We have exposed 9000 port at our host container, sorry, at our container, in our container, but we will locally expose, suppose 9090 port. 9000 node demo. Server started at port 9000. Okay, cool. Let's run local 9090. Okay. Cool. 9090. Congratulations. Hello world. Awesome. So let's do one more thing. Docker ts grab node docker stop docker rm cool. So the problem here is now we can't leverage our caching policy here. So suppose if we make some changes like hello world to, it will start building our image again. Docker build node demo. So it is only cached this make directory only, but didn't catch run npm install and update part. So what we can do is we can follow some of the best practices that Docker comes up with. So we can copy only package to app directory and then run install, and then we can copy dot to dot. So what it means, there is no change in this command, there is no change in this command, there is no change in package.json file, as we are not installing any other dependencies or any other packages, and so there is no changes in this command. But while copying this file, while running this command, there is a change in the index.js file. So it will cache all these 5 layers and start building files from here only. So this is the like major improvement while building an image. So we can leverage cache policies of Docker. So copy dot expose 9000 and then run this Docker build. So first time it won't cache, as this is the first time we are running a set of commands to build our image, but we in second time when we run the same commands it will cache. So as we can see, it is not caching here, but let's make some changes here to doc hello world 3 and then again build this. We can see cache. So this is using a cache, this is using a cache, using cache, using cache. So all these layers are already cached. We have only these layers which is rebuilded. So docker run again, and now we can see hello world 3. Awesome. Let's stop this container. Docker. Docker stop, or you can rerun your containers. Start and stop. Cool. Let me show you how we can distribute our images with some other developers, fellow developers. So we have Docker image grep node. We have this image node demo. So now what I can do is I will go here, create a repository, Docker demo node. Docker demo node, keeping it public, create. Okay, so the name of the image is Ankit 20 because this is the name of my username, and this is the name of the repository, similar to GitHub. So now we can tag our image Docker tag node demo to Ankit Jain 28 slash this, and then we can pass any tag like latest. Latest is default tag, we can pass version 1.0. Cool. So now we can see our image here. Cool. Let's push. So we can Docker push version 1.0. The push refers to Docker IO, this repository. So here there is no image as of now. We can see there is no image. Okay. As soon as the image is being pushed, we can see our image. Cool. So our image is pushed. Let's see. So we can see our image here, version 1.0. So if you want to run the same application, this node application over your system, you can simply run docker pull this image, docker copy this command, docker pull version 1.0, download this image. It will pull the image, and then docker run -p 9000 port container port, name of the image, tag of the image, and run. Server started 9000. Go. Cool. So in this way, you can easily distribute your project's images across your fellow developers by building images, running them as a container. Cool.